Welcome back to Brain Lags. Today, we're pivoting away from the stars and diving straight down into the pitch black of our own planet to explore a world that totally defies human logic. Down in the freezing Antarctic waters, you'll find sea sponges the size of minivans and squids 14 times larger than those near the surface. It's a strange paradox of human exploration. We have actually mapped the surface of Mars more thoroughly than we have mapped the bottom of our own ocean. The physics of the descent are hostile to life. You're dealing with zero sunlight, near freezing temperatures, and a crushing pressure of up to 1.1 kilobars. To put that in perspective, that is the equivalent weight of 50 jumbo jets pressing down on a single square inch of your body. Yet, despite that extreme physical environment, the ocean's twilight zone is packed with biology. Researchers estimate that up to 90% of all the fish in the world live right in this dark region.
Descending into the darkness places you inside an active biome of adapted monsters, where survival depends on a mastery of impossible physics. If you were actually down there, the pressure wouldn't be the only thing overwhelming your senses. The deep ocean is shockingly loud. Researchers have recorded an eerie, low-frequency hum echoing through the depths. It peaks specifically at dusk and dawn, caused by billions of unseen creatures moving up and down the water column to feed all at once. Then there are the isolated anomalies. In 1997, highly sensitive underwater microphones picked up an incredibly loud rumble from over 3,000 meters away. It was called the bloop. For years, experts legitimately suspected it was the call of an unknown, massive marine animal, before finally identifying it as a cracking ice shelf. The creatures navigating these loud, dark waters are subject to a biological phenomenon called Deep-Sea Gigantism. In an environment with extreme cold and very little food, many of these invertebrates drastically slow down their internal metabolisms, which allows them to mature later and grow to massive sizes. This sluggish pace is incredibly efficient. A 43-foot giant squid weighing nearly a ton can survive on just 45 calories a day. That's a single 1-ounce fish sustaining a massive predator. In a realm where starvation and near-freezing temperatures are the default state, growing into a giant, slow-moving energy vault is the ultimate survival mechanism. But that brings up an obvious physiological problem. How do these massive bodies avoid being instantly flattened by the weight of the ocean above them? It comes down to density. Surface animals, including us, have internal spaces filled with gas, which compresses under pressure. Deep-sea creatures lack those air gaps. Their bodies are primarily made of water, and water is completely incompressible. At a cellular level, they rely on a specialized chemical called TMAO, trimethylamine and oxide. This animated diagram shows exactly how that works. Under intense pressure, the normal network of water molecules inside a cell distorts. TMAO acts as a structural chemical anchor, physically reinforcing the hydrogen bonds and stopping the cell from collapsing under the ocean's weight. The catch is that they are entirely dependent on that external pressure. If you pull a deep-sea creature up to the surface, the sudden lack of compression causes their tissue to expand, turning them into a floppy mass. In the abyss, water pressure acts as a biological scaffold, providing the external force necessary to hold these creatures' bodies together. If you keep descending all the way to the ocean floor, you run into geographical features that are even stranger. Specifically, underwater lakes known as brine pools. These are ancient, motionless pockets of water sitting directly on the seafloor. The water inside them can be up to 8 times saltier than the regular ocean water immediately surrounding them. Because of that extreme salinity, these pools do not mix with the rest of the ocean. They are completely devoid of oxygen, which makes them toxic death traps for normal marine animals that accidentally wander over the edge. Inside these oxygen-free, toxic zones, researchers have found entirely unique ecosystems. They are filled with specialized microbes in strange mineral formations that have evolved to thrive in this specific chemical soup.
The ocean floor functions as a complex mosaic of extreme, deadly microworlds, each dictated by a unique set of biological rules. When early sailors caught fleeting glimpses of deep-water giants washing ashore or surfacing in the dark, they didn't understand the complex biology at play. They invented monsters. Look at this historical map. Without science to explain the massive tentacles or the sheer size of what they were seeing, human imagination filled in the blanks with sea serpents and giant beasts attacking ships. Some of those terrors did exist, just at the wrong time in history. The megalodon was a massive shark, but it went extinct over 2 million years ago. Today, the only concrete proof of its existence are fossilized teeth like this one, measuring over 7 inches long. But other legends overlap with reality. The Norwegian myth of the Kraken, a creature said to be large enough to drag entire ships underwater, was almost certainly inspired by real encounters with the giant squid. This is a photograph of an actual giant squid carcass. Stretched across this table, with the researchers right there for scale, you can see how its massive mantle and incredibly long tentacles rival the nightmares of early sailors. The mythical monsters of human folklore might be exaggerated, but the actual biological products of deep-sea evolution are every bit as intimidating, and we are still finding them. Down in the deepest points on Earth, in the Mariana and Tonga Trenches, life manages to carve out a foothold. Researchers have found supergiant amphipods scavenging on organic debris called marine snow, and entirely alien ecosystems clustered around hydrothermal vents, like the one in this photo, pulling their energy directly from volcanic heat and toxic chemicals. The most chilling fact is how little we actually know. Humanity has thoroughly explored barely 5% of the global ocean, leaving a massive expanse of our own planet hidden in total darkness. If you were descending in a small, glass-domed submarine right now, which of these deep-sea giants would terrify you the most? Let us know in the comments. Thanks for watching Brain Lags. The most mind-bending mysteries in the universe don't always require a rocket. Sometimes they are waiting for us right here, in the crushing darkness of our own planet.